So this is from Unit 3, Homework 3, problem number 14, where we are being asked to subtract square root of 45 and the square root of 180. So we know since these are not like radicals, one is 45 under the radical sign, the other one is 180 under the radical sign, we can't subtract these. This is like trying to subtract x squared and x to the third power. They're not like terms. By the same thinking, these are not like radicals. So we want to simplify each radical first and see if they become like radicals so that we can then combine them. So first let's look at the square root of 45. And I have on the right side of the screen a list of perfect squares for you so that you can be thinking about what factors we could have in 45 that might be a perfect square. Because remember, we could factor this as the square root of 5 times the square root of 15, but neither one of those are perfect squares. So starting at the bottom of the list, I'm looking at each one. 49 will not go into that. 36 doesn't go into 45. 45 divided by 25 is not an integer value. It doesn't go evenly. 45 divided by 16, that's a decimal. But 45 divided by 9, that gives me an integer value. So I can rewrite the square root of 45 as the square root of 9 times the square root of 5. That's the same value as the square root of 45. And then let's look at the square root of 180. Again, I'm going to start at the bottom and look at what numbers will go into 180. And I didn't go all the way down, but we could go farther, all the way to 15. That's probably far enough. But I'm looking at 100, doesn't go into it. 81 doesn't go. 64 does not go into 180 evenly. Dividing by 49 gives us a decimal. 180 divided by 36, though, gives us an integer value. So we can rewrite the square root of 180 as the square root of 36 times the square root of 5. Now, let's simplify what we have. Square root of 9 is 3, and that's times the square root of 5, and then subtract. Square root of 36 is 6. Without the radical now, we've taken the square root of it. We have found what number times itself twice gives us 36, and that is the integer 6. And that is still times the square root of 5. Well, now what we have are like radicals. We have 3 times the square root of 5 minus 6 times the square root of 5. And you can think of these as like radicals. So 3 of these minus 6 of these gives us minus 3 of these. And those are square roots of 5. But you could also use the reverse of your distributive property. Come down here and factor out a square root of 5. And when you do that, you take your square root of 5 to the outside, you have 3 minus 6, and that again gives us negative 3 times that square root of 5, and that's the usual order that we write those in. So let me know if you have any other questions.